I could also do like that. Okay, and I have the double bond on the left, and here I have it on the right, and at first you think it makes no difference at all, and if you showed me either one as an answer, I'd say you're right. Also, molecules. This sulfur dioxide is a gas at room temperature and pressure. It is a very common air pollutant. And if you breathe it in, you start, your eyes burn, your mouth, your nose, everything burns, because when this stuff hits moisture, it turns to sulfurous acid. So if you breathe some of it, a student in my class yesterday used to work on air conditioners and stuff, and he said in the old days they used sulfur dioxide as a coolant in them, and every once in a while when he was working with them, he'd get a blast. He discovered yesterday in class why that burned his nose. Is because he had turned himself into a little acid factory by the moisture in his nose and his mouth and his eyes. Okay, I can write it this way and I can write it that way. And yes, a gas molecule particularly, these things roll and tumble and move around on space. But let's pretend we can nail this down. And I could tell one oxygen from the other. These are nailed down. So, this time the red has a single bond, and this time the red has a double bond. Okay, here's the story. This is the new part. When you can write Lewis dot structures in two or more logical ways, meaning everybody has an octet, and you just have them different by a multiple bond. It can be a double or it can be a triple. Reality was actually found to be neither one. That. For this and any other substance we draw, where this is a correct answer, that is a correct answer, reality is found to be kind of a mixture of the two. Okay, so this is really like a bond and a half and a bond and a half. It's not truly a double or a single. And you say, how would you ever know that? Meredith, was it you I saved from falling out the window at the hotel? Okay, double bonds are stronger bonds. Remember when I was saving Meredith? 1 point of contact versus 2 points of contact to keep her from falling or jumping out the hotel window? Okay, that should be a stronger, shorter bond. So if this were true, we should find one stronger, shorter bond and one longer, weaker bond. That's not what was found at all. When you take it to sophisticated labs and they can actually measure bond length and bond strength, this is like intermediate between a double and a single. It's like a bond and a half as far as length and strength. We call this resonance. Okay, what we say is, I've got some sulfur dioxide, and this is what you have to be able to do. How many resonance structures can you draw? The answer is 2 for this particular thing. That you count this and you count this. And then you realize, and organic chemists make a bigger deal of this, reality is a mix. And when you do have resonance, it's found that reality, that compound, is more stable than you would expect by just looking at this. Okay, now let me give you a couple of analogies because I want you to understand. This is not flip-flopping back and forth, because that's what the word resonance makes you think of. You think, it's a double here, and then it's a double there, and it's a double here, and it's a double there. No, no. It is 100% of the time like this. So let me give you 2 analogies. Here's the one that I think is in your book. If you take a horse, and you cross it with a, horse, you cross it with a donkey, what do you get as an offspring? A mule. Okay? It is a mule 7 days a week. Every hour of the day, every minute of the hours. It is not looking like the horse Monday, Wednesday, Friday, and looking like the donkey on Tuesday, Thursday, Saturday, or whatever. No, it's a mule all the time. It doesn't switch back and forth, which is what the word resonance would lead you to believe. Here's the horse. Here's the donkey. The mule. The reality is the mule. But here's one I like better. It's in the organic book, if I can get this straight. This is really imaginary. This doesn't exist like this. This is imaginary. We just write it on paper and I give you points for it. Okay. Reality is over here. So these are imaginary, that's real. Okay, team. Why don't you take a dragon, an imaginary animal? You know, the old kinds of dragons with breathe fire. Don't get smart and say there's Komodo dragons in Southeast Asia or wherever they are, in the South Pacific. No, I'm talking dragons, fire-breathing dragons, an imaginary animal, right? I'm going to cross it with a unicorn, an imaginary animal. You know, unicorns? Don't argue with me. I had a student one year insisted unicorns were real. No, please. Unicorns, imaginary. Okay, dragon, imaginary. I'm going to cross them. Guess what my offspring would be? No.
A unit dragon?
Okay, think of an animal. What'd you say?
Unit dragon?
Unit dragon. No, it's a rhino. A rhinoceros. Think about it. Dragons are big and ugly. Rhinos are pretty big and ugly. Got a on the front. Kind of like a unicorn. It's a stretch. But the organic book uses it. I love it because, come back over here. Imaginary. That's the dragon. Imaginary. That's the unicorn. We mix them, we get our rhino. Okay, and that's real.